This is just showing you, again, positive slope, negative slope, zero slope, and undefined slope. So you want to memorize these, and that's just the information we went over on the previous page right there. Same thing. We want to have all three of these items must be associated with each other, right? Y is constant, zero slope, horizontal line. X is constant, undefined slope, vertical line. So that's you need to memorize that. Find the slope of a line from its equation. Okay, so when we find the slope of a line from its equation, we're going to use something called the, oops. There we go. Okay, so we're going to call this the slope-intercept form of the equation, slope-intercept. And you really want to memorize the name of this because whoops, because it's going to be referencing this by name on many problems. It's going to ask you to put something in this form. And all they're really saying is they want you to solve for y. Solve for y, right? Okay. Now, once you do this, you get your m. It's going to be the coefficient right there. But also, you get your y-intercept from this as well, which we're going to go over in a bit. Y-intercepts always have a 0 for the x value, and whatever that constant is at the end there, that's going to be your y value of your y-intercept. So again, slope-intercept, you solve for y. Whatever coefficient you have in front of your x here, that's going to be your slope. Don't include the x. And whatever the b value is, that's the y value of your y-intercept. Okay, so let's do a couple examples of this and hopefully it'll make sense. So find the slope of each line. And we know how to do it. We want to solve for the variable term with the y. So we're trying to get that by itself. So we have to get rid of that positive 2x there. And we do that by subtracting 2x. And whatever we do to one side, we do to the other. Those cancel out. That leaves me negative 5y is equal to negative 2x plus 4. Next, I want to undo the multiplication of y by a negative 5 by dividing by negative 5. Whatever I do to one side, I do to the other. Cancel, cancel. That gives me y is equal to, now a negative 2 divided by a negative 5 is the same. It's going to be a positive. And then we have a positive 4 divided by a negative 5, so it turns into a minus 4/5. Okay. And since they only ask for the slope in this case is going to be the coefficient in front of the x right there, so it's going to be this 2/5, right? But they didn't ask for this, but I want to answer it anyways just for practice. We're going to be using this later on. If I wanted to find the y-intercept from this information right here, from the slope-intercept form, then that's what I would do. That would give me negative 4/5. Negative 4/5. There you go. Okay, so let's try it again. So let's say, oh, there's obviously a typo here that is on me. Let me fix that. So let's say that was a y arbitrarily. Okay, so we want to get this by itself. So I would subtract 2 and I would subtract 2. Cancel, cancel. That would give me 8y is equal to 2x minus 1. Then I would undo the multiplication of y by 8 by dividing by 8. And whatever I do to one side, I do to the other. I did this one a little bit differently in that I wrote the division by 8 over the whole thing. But then immediately I would have to break it apart so I can simplify further. So that's why I broke it apart before into two separate divisions or two separate fractions over there. Okay, now I can simplify 2 over 8 to 1 over 4. And then I would end up with this. Okay, so the slope in this case is 1/4 right there. And the y-intercept in this case is going to be this whole thing right here. We're going to stick it in there, including the negative. So negative 1/8. Negative 1/8. There we go. And we have one more case. We want to solve for the y, so we want to get this entire variable term with the y by itself. So we have to undo the subtraction of 5 by adding 5, and whatever we do to one side, we do to the other. Those cancel out, leaving me 3y is equal to 2x, and then negative 3 plus 5 is plus 2. Then we undo the multiplication of y by 3 by dividing by 3. Whatever we do to one side, we do to the other. Those cancel out, leaving me y is equal to 2/3 x plus 2/3. And now we want the slope. The slope is this number right there in front, which is a 2/3. And just to be thorough, I'm also going to derive the y-intercept from this. And it's going to be that right there. 2/3. So now we're going to use the slope-intercept form basically to graph. Okay, so we're going to identify the slope and the y-intercept using this form right here, which is the slope-intercept form right here. And then based upon that, we are going to graph the equations. Okay, so this one's already solved for y. So first we're going to get the slope from it, which looks like it's a -4. And we also want to get the y-intercept from it, which is a 0, 1. Okay, now based upon this, how do I graph it? Okay, first I'm going to plot. So first, looks terrible. So first, plot y-intercept. Plot y-intercept. Okay, so that's what I'm going to do. I have 0, 1. I'm going to use a different color so we can see it though, okay? So let's say we go up 1, and, we just stay in, so we just go 0, that's your x value right there. So that means you don't go left or right. And then you end up with a y value of 1 right there, which means you go up 1. So I plotted the point. Okay, now what you're going to use second, you're going to use the geometric interpretation of the slope. Sounds terrible. Your interpretation of slope. That's way more complicated sounding than it is. Interpretation, something like that, whatever, of slope. Which basically means m is simply going to be vertical over the horizontal, right? So in this case, our slope is the -4, right? So the slope, let me scroll up a little bit. Our slope in this case is a -4, and that's understood to be over 1. Now that means we're going to go down 4 into the right 1. That's how I would interpret that, right? So again, it's rise over run. We're doing the opposite of what we did previously, where previously we were given a graph and we would interpret the rise over run over the rise, and then we would interpret the run. Now we're going from rise and run, and we're going to interpret that as where we're going to find the next point. So from here, we're going to go down 4. From the y-intercept, we go down 4. 1, 2, 3, 4. And then to the right 1. Bam. We plotted a point. We can even do it again if we want to be a little more thorough and having more points. 1, 2, 3, 4 over, 1, 2, 3, 4 over 1. We can do it over and over again if we want to. And what you would end up with, if you did it that way, is something. Oh my gosh. I'm trying to draw a straight line. Yeah, it's not perfect or anything, but there we go. And you end up with your graph. Okay, so again, first step is to plot the y-intercept. Second step is to use the geometric interpretation of the slope to find the second point. And it's just rise over run. So you do exactly what the slope tells you, and you find your second point. If you want to, you can even find a third point. Third point's more of a check though, right? You can draw a line through any 2 points, but if you draw 3 points and one of them is off, right, that will tell you that your graph may be wrong. So the third point is just a checkpoint. Okay, so let's try it again. Okay, so here we go. So it's already solved for y, so we know the slope is the understood or implied 1 coefficient there, so it's a slope of 1. And it's understood to be over 1, of course, 1 over 1. You don't have to write that, though. And then we have a y-intercept of 0, -8. So we just plug that -8 right there. Okay, so first thing is we need to plot this 0, -8. So I'm going to plot it right there. Okay. And then next, I have a 1 over 1. Well, that's going to be a +1 over a +1. So I'm going to go up 1 and to the right 1. And I can keep doing this as many times as necessary, and every one of those points needs to be on this line. So let's see if I can draw a straight line this time. That's better. Okay. So there you go. I graphed it. Let's try another one. Okay, this one right here, we know the slope is going to be this right there. That's 6. And this one is going to be a little tricky, but not really too much. Basically, because you don't see a constant, it's basically saying, well, you're adding a 0, right? Okay, so it's 6x plus 0. It's that you don't see the constant, but the constant must be 0. They're adding 0 to 6x. Okay, so it turns out that in this case, your y-intercept is the origin right there in the middle. Okay, now we have a slope of 6 that's implied to be under 1. Okay, I'll write it over here so we can see a little better. 6 over 1 means we're going to go up 6 and to the right 1. So up 6 and to the right 1. Okay, so I'm going to try to draw this line. It's curved. All right, that's reasonably close, I hope. And there's my graph. My math lab will do a better job of this than me, obviously. Okay, and the last example of this right here on this page is our slope is going to be, this looks weird, but there's an implied or understood 1 in front of that x there. So you could really rewrite this. Right, so x over 4 is the equivalent of 1x over 4, which is the equivalent of 1/4 x off to the side, right? So these are 3 ways of writing the same thing. So I want to grab that right there, that 1/4. Hopefully that makes sense. Okay, next, I want to find my y-intercept. And my y-intercept is 0, and then we plug this in, -3/4. Now, this is a little more complicated in that it's going to be really difficult to plot this point there, the -3/4. All right, so -3/4 is going to be down, not quite to -1, but pretty close. And that looks like the slope is 1/4. So the geometric interpretation of the slope, 1/4, is going to be up 1 and to the right 4. Up 1 to the right 4. All right, so up 1 to the right 4, right about there. And then up 1 and to the right 4, and then we just basically draw a line through that. I'm going to do my best. Yeah, it's not ideal. I don't know. I'll do that